you. Well, first, thank you all for being here, and thanks to everyone everyone whoever assisting on site. I'll introduce myself a bit. I'm Aqeelah Shahabdeen, currently working as a statistics demonstrator at University of Peradeniya. I'll be joining virtually to conduct this workshop on mastering R for statistical analysis. I know it might feel a bit different while being with me while I'm online and you all are on site, but I'll try my best to conduct this session interactive as well as hands-on. Uh, Always feel free if you have any questions at any point, feel free to ask. Okay, I'll start my session by sharing my screen. I'll turn off my camera distract to avoid distractions. Uh, I cannot share my screen.
Wait, madam, I'll give you host.
Okay.
Madam, can you share now?
Yeah, I can share. Is the screen visible? Can you all see my screen?
Yeah,
We can.
Okay, thank you.
It's
It's mastering R for statistical analysis. First, can I know, has anyone tried using R or R Studio before?
Madam, we have downloaded both R and R Studio for our PCs, so they are ready for work.
Okay, thank you. If you it's totally fine if you don't have any experience with R or R Studio up to now. In this workshop, we will be covering following key topics to get you familiar with R for statistical analysis. I'm going to cover introduction to R and R Studio and workflow, basic R concept, data exploration and visualization, statistical methods and analysis in R. Okay, now we look at why we learn R. Why learn R? Because effective data handling and storage. In R is great for managing all small data set as well as very large data sets. R is very effective for data handling for all those types of data sets and powerful statistical and mathematical capabilities. R is specially designed for statistics, offering many tools for analysis as well as modeling and visualizing data, make it top choice for data professionals. And the major thing is flexible and easy to learn programming. R is beginner friendly with simple syntax, so you all can learn R very easily and it's very flexible. Okay, it's an open source and widely used in industry. So you all can install R as well as R Studio in your own machines and you can work on it. It's totally free and has large community. It's widely used in industry like data science, finance, healthcare. So learning R opens many career opportunities. Now we'll look at what is R and R Studio. R is a programming language for statistical computing and data visualization used in data analysis, machine learning, and research, mainly in research. In our university, for for all undergraduate research, final year research. For analysis part, we mainly use R Studio for data analysis. Okay, now I'll show R interface. This is the R interface. Hope you all can see it. This is our R interface. In here, you can just, I'll show the R interface. This is our interface. You can see here, there is only the console window. In our interface, you can just type any mathematical calculations. In here, I just type 4 plus 6. Likewise, you can type any mathematical equations. If you press enter, you can get the output, right? This is our R interface. Now we'll move to R Studio. What is R Studio? Right? R Studio is an integrated development environment for R. Provides an easy to use interface for writing and running code. Since R Studio runs on R, first if you want to use R Studio, first you all have to install R, right? For most of our work, we usually use R Studio because it's very user-friendly environment, as well as we can save our work easily. I'll show the R interface. Now you all can open your R Studio. In your machines, you all can open R Studio. Today, we are going to look at R Studio specially. R Studio, to get R Studio, you all have to install R first. But while comparing to R Studio is very user friendly and we can save all our work easily. So if you want to do analysis in R, we usually use R Studio, not R, right? Okay, hope you all can open R Studio. You all have opened R Studio in your machines. In here, you all can see the R Studio interface. This is our console window. It's similar to R, right? In here, there are many tabs: file, plots, packages. In here, you can see environment tab, history tab, connections. Likewise, there are many tabs here. While working on our data set, you can get more familiar with these tabs, right? Now, as I mentioned, this is our R interface. First, you all can see environment history, the environment plane here. Likewise, file, plots, packages, you can see these tabs as well, and console window. While opening R, you cannot see this program plane, right? Okay, hope you all have opened R Studio in your machines. You only can see your console window and these tabs, right? Now we'll look at what is R project. R project. R project means while working on dataset, we'll work with several projects. While working on those projects, for each project, we open new R project, right? If you open a new R project, you can have a new working directory. So while working on several projects, we usually open R project for each and every project we open our project, right? While working, our projects means our studio projects make it straightforward to divide your work into multiple contexts. each with their own working directory, workspace, history, and source environment. R Studio projects are associated with R working directories. You can create a R Studio project in a brand new directory as well as the existing directory. Now we are going to work on a mini data set today. For that data set, now you all have to open a new R project, right? Follow the steps. Hope you all are following the steps. If you want to open a new R project, open R Studio first, then go to File, New Project, File, New Project. Then before that, you can open a folder in your desktop. I don't know whether it's okay in your desktop. If you have any specific drive, you can open a folder in that drive. In here, I'm going to open a folder in my desktop. You can name it with any name. In here, I'm going to name it as our workshop, right? First, open a folder in your desktop, or first you all can open a new R folder, right? Now we are going to open a new R project for today's session. File, New Project, File, New Project. After that, existing directory. Then browse your folder. Open. After that, you can create a new project. If you create a new project, you can see a new working environment. In here, I am having a new working environment. My environment tab is empty and history is empty. All tabs are empty because it's a new working environment. If you want more time to create a new project, please let me know. Then I can wait for a few minutes to open a new project. File, New Project, existing directory, then browse your folder. After that, create new project. If you want more time to create project, please let me know. Did you all create a new project for today's session?
Madam, you can continue. Everything is fine now.
Okay, thank you. This is our new project. You can see our environment and history tabs all are empty, right? Now, what is R script? You can see if you type any commands in your console window, it's same as R. R means this interface, right? It's same as R. If you type any commands in R console window, if you press enter, you can get the output. And if you type any commands in console window, you can get the output there, but it's same as R. But it's difficult to save your works while analyzing the data set. If you type all the commands in your console window, it's difficult to save your R commands and analysis part. So we have to open a new R script. Now you all have to open R script, file, new file, R script. File, new file, R script. You all can open a new R script in your new project, right? Now we are going to type all the commands in our script. Then you can see the output in your console window. After that, we can save our R script. This is our R script. First, we'll save it. File, save as. Then select that specific folder which you all have created. Right? Give a name for it. You can give any name. Save. Right? Open a new R script and save. Hope you are done with it. If you want more time, please let me know. Then I can wait for few minutes, right? Now you can type any commands here in your R script. You can just type any mathematical calculation. If you run this command, you have to press this run button. You can see in your tab there is a run button. Place your cursor in this line, then press run button. If you press run button, you can see the output in your console window, right? And all your commands are in the R script, and you can see the output in your console window. After working on it, you can save your R script, right? You can you can type any mathematical equations, right? It's 5 minus 3, it's 2. If you want to run this command, keep the cursor here. After that, press run button, or you can just type control plus enter. Control enter. If you press control enter, also it's a shortcut for this run button. You can get the output, right? Did you all done with it? Open a new R script, then just type some calculations. After that, run that command. If you want to run, you can use this run button, or else you have to just press control plus enter. Control enter, right? Then you can run all these commands. Is it okay? Open a new R script and just type some calculation. After that, run the command. If you want me to explain it again, I can do it. If you need more time, please let me know. Did you all have done with it?
Yes, madam, all are done.
Okay, thank you. Now, this is about R script. If you want to save all your commands in your R Studio, you have to open a new R script, and you can just type all the commands. After that, you can save your commands easily, right? That's why we are using R Studio. We don't use R because it's very difficult to save all your records in R. So for our analysis part, we usually use RStudio, right? To execute the commands, leave the cursor anywhere in the line where the command is. You can just click run button. Run button is here, right? The OS, you can press just control enter, right? Now we'll look at what is R Markdown. R Markdown is in our analysis. If you want to write a report about your analysis, we usually use R Markdown files, right? It's better to use R Markdown. I'll explain why it's better to use R Markdown while writing your report, right? A document that combines code, text, and visualization, support multiple output formats, easy to write with Markdown syntax, code plus output in one document. I'll show you our Markdown file. Right, I can show you our Markdown file. Uh, then you can understand it. Okay, this is one of our Markdown file. Right in here, you can this is our R command, and this is our R command, and this is our output. Right, you can get all R command and outputs in the same document. If you want to convert it to a PDF or HTML file, you can convert it if you use R Markdown. Right in here, this is R command, and if you want, you can type any interpretation about this output. This is R command, and this is the R output, right? You can get all your commands and the output in same documents. So if you want to write any reports regarding your analysis, we usually use R Markdown, right? If you want to open a R Markdown file here, this is our R script. Go to File, New File, after that R Markdown, right? Hope you all are following these steps. I'll explain it again. File, New File, R Markdown, right? In here, you have to give a title. You have to give a title. You can just type anything. In our analysis, we usually type the title. It's for example, it's cluster analysis. Likewise, we'll give the title. In here, I'll give it as our workshop, right? Author, you can give your name here. After that, you can select default output format as HTML. It's okay. After giving HTML, you can convert it to PDF as well. Then, okay. This is our R Markdown file, right? Hope you all open our Markdown file. If you open our Markdown file, you can see there are default commands, right? Default R commands, right? You can run all these commands using this button. In here, you can run. This is, I think you all cannot understand these commands. It's okay. Just press the run button and run the commands and see the output. In here, we are getting a plot. After that, we can type anything. I didn't type any commands here. It's while opening our Markdown file, you can see some default R commands, right? You all can run those commands and see the output, right? Now, if I want to add a command to this R Markdown file, sorry. If I want to, you have to go here Uh, Hope you all can see the screen clearly. You can press this button and insert a R chunk. Right? If you insert R chunk, you can see like this and you can type anything. Just type, for now, just type some mathematical calculation. After that, you can run this command. You can get the output here. Right? In next line, no need to go to the console window. You will have the output in your console window as well. But while writing a report, it's better to open a R markdown file. Then you can get the output near to your command, right? If you want to write a command, first keep your cursor here. Now you can go open a new R chunk. Then in your R chunk, you can type anything. Then run this command and get the output, right? After that, you have to save your R markdown file. Save your R markdown file. You can give any name. Okay, save R markdown file. Then, sorry. Then you can knit this R markdown file to any folder. In here, there is a knit button. Knit, knit to PDF, knit to HTML, knit to Word. You can use any of these. I hope you all cannot knit it to PDF because in your machines you have to install some packages to knit to PDF. So now you all can give knit to HTML. We'll see the output. In here, we'll get a HTML file with all our interpretations and our commands and output, right? While doing a statistical analysis, we usually use our markdown file. Then we can get it as a PDF or Word document with all our commands and output, and we can write something, we can interpret those results. So we usually use our markdown files, right? You can knit it, for now, you can knit to HTML. I hope you will get some error if you knit to PDF. In here, I can get the PDF. You have to install some packages to get knit it to as a PDF, right? Now you can just click knit to HTML and you can see the output. You can have a HTML file with all these commands and output, right? In here, I just type some calculations. You all can add more calculations. If you want R chunk, click here and R. Then you can type anything in this chunk and you can run those things, right? This is our R markdown file, right? It's okay to continue the session, or do I want to wait for a few more minutes?
Madam, please wait for 1 minute.
Okay.
Madam, there is a small suggestion from our students that to do this a bit slow. Is that
Okay.
okay?
Do I want to explain it again?
Okay, well, they're asking, yes, madam, they wanted to explain it again.
Okay. Then I'll explain R markdown again. If you want if we want in our analysis, if you want to write a report, we usually use R markdown files, not the R script, right? It's okay. You can do your analysis in your R script. If you want to get it as a report, usually in our research we write a report after for our analysis part. For we usually use R markdown files. To open R markdown file, go to File, New File, R markdown, right? To open a new R markdown file, you can go File, New File, R markdown, right? Is it okay? If you want to open R markdown file, go to File, New File, R markdown. Then you can give any title. In here, just give any. We usually give our uh, project title, and you can give author name. After that, select HTML here, then OK, right? Then you will get a R markdown file. To get a R markdown file, File, New File, R markdown. You can just type any title. After, give your name for as a author, HTML, press OK. Then you will get a R markdown file like this, right? Did you all open a R markdown file?
Yes, madam, they have.
Okay. Now, if you open a R markdown file, you can see there are, by default, there are some R commands, right? It's not, our markdown file is not like a script. In your script, it's totally empty. You can just type any R commands and run those commands. In R markdown files, there is a title, author, date, output. This is a format to write a report, analysis report. So they already have title and author, date, output, right? Now they, by default, you will get some R commands, right? For now, I know you all don't have any idea about this R command, but you can just run these commands and see the output. To run this command, you can see in here it's gray color line. This is our R command. You can just run this command by clicking this green color run button. Run current chunk. If you press it, you can see the output. In here, they don't have any output because it's kind of set up. In your second chunk, if you run this chunk, you can get the output, right? I know for now you don't have any idea about these commands and the output. You can just run these by default commands. You can press this run button and see the output, right? After that, this is our command. You can see it because it's our chunk is in a different color. So if you press this run button, you can see the output, right? It is giving a plot, right? Did you all run these commands?
Jaffna. Hello.
Hello.
Yeah.
Okay. Now if you want to add some commands, you can go to this insert a new code chunk in here. I hope you all can see clearly. You can press here, go here and select our first line. It's inserting a R chunk, new R chunk, right? If you want to add some commands to this R markdown, you can keep your cursor here and press this button and add new R chunk, right? After that, in your R chunk, you can type any R commands and you can run those commands, right? To get a new R chunk, go here. There is a C symbol. After that, press first line. It's inserting a new R command. Now you can type anything and run those commands. Then you will get the output. If you want to add chunk in R markdown file, you have to do like that. Insert a new R chunk, then type the command. After that, you can press the run button and see the output. Right. Now, this is our R markdown file. Right. Up to now, is it okay? Oh, okay, ma'am. Okay. Now you can knit this R markdown file. First, you have to save your R markdown file. Hope you all know how to save. File, save as, give a name. You can give any name and save. Save your R markdown file. You can see here it's your name dot extension RMD. If it is a R markdown file, the extension is .rmd. Right? Now you can knit this RMD file as a report, right? If you want to knit it as a report, here you can see the knit button, right? Knit button. In the knit button, there is option knit to HTML, knit to PDF, knit to Word. Right? Likewise, you all have several options. In here, you can just press knit to HTML and you can get all these commands as a HTML file, right? This is the way to write a statistical report using a R Studio, right? You have to open a R markdown file and give all your R commands. Then you can get the output in document and you can write anything and you can interpret. If you want, you can comment and you all can knit it to a HTML, right? Press knit button and select knit to HTML, right? In my machines, I can knit it to PDF as well. I hope you all, if you press knit to PDF, you will get an error because you have to install some packages in your machines. So I hope you all can, you all cannot get a PDF. So for now, you can knit it as a HTML file and you can see the output, right? I can show you a PDF. I showed it. I have showed it. I have shown it, right? In here, you can see all our commands and our outputs with the interpretations. This is the way to write a statistical analysis report using R Studio, right? In here, you can see all your R commands. If you want, you can comment anything and you can see the output. Likewise, this is our R markdown file, right? You can knit it to a PDF if you install that specific packages, right? For now, you can knit it to a HTML, right? This is a R markdown PDF file, right? This is
Madam, could you
okay.
please zoom your PDF because we can't see it properly. It's better to zoom.
Is it okay now?
Yes, madam. It's fine now.
Okay. In here, you can see all your, all, this is our command and this is our output, right? If you want to interpret anything, you can write it in your R markdown file, right? Then you can knit it to a PDF, right? Likewise, you can get a clear and nice report for your analysis part. This analysis about Bayesian analysis, I don't know whether you all are familiar with those things. It's not need. You can just see the PDF and report, right? Okay. Now, as I explained, if you can open a new R markdown down file to write all your reports, right? But for now, we are going to use R script. I especially want to introduce the R markdown file in this session. Then you all can write a report and knit it to a PDF, and you can post all those analysis in LinkedIn likewise, right? Let's get started with R. We have already started it. We have created a new project and create a new R script. If you want to open R script, go to File, New File, R script. And now we all are going to write some R commands, right? Run your, and you all are familiar with this R markdown file as well. Perform the same task using R markdown file, right? Now, in your script, we just now go to script. You can select script here. That's all about our markdown file. You all can run all the commands you learned, which you learned in your R script. You all can run all those commands in R markdown as well, right? Then you can knit it to as a PDF, right? For now, we'll practice our commands using R script, right? In here, I am going to use the R inbuilt function print. Print. It's an R inbuilt function. Within print, inverted commas, in between inverted commas, you can type anything. Hello R. If you want to run this command, as I mentioned earlier, you can use this run button or else control enter. Then you can see the output in your console window. You cannot get the output here because it's R script. If it is R markdown file, you can get the output near to your R command, right? If you run this command, you can see the output in your console window, right? Did you all run this command print hello R or anything? You can write anything in bracket. After that, you have to put inverted commas. Within that, you can type anything. Just use the R inbuilt function print. Is it okay?
Yeah, madam, it's okay.
Okay. Now we are going to do some basic calculations in R. We have done it earlier. I want to mention you have done some addition and subtraction. As well as there are many R inbuilt function. One of that is print, right? We have used print. In your R script, you can, as hope you all can see my R script. You can do some divisions. To do division, you have to use slash mark here, right? Slash. Likewise, you can do multiplication. You have to use 3 into 2, you have to use star mark here, right? Likewise, you can do many mathematical calculation, but you have to use these symbols, right? If it is a division, you have to use this slash, and if it is a multiplication, you have to use this star symbol. If you want to find the modulus, you have to type 2 percentage mark, then 3, run the command, then you can see the remainder is 1, right? If you divide 10 by 3, the remainder, you will get the remainder, it's modulus. You have to use this 2 percentage symbol, right? If you run the command, you can see the output in your console window. Sorry. Right? Okay, now we are going to use some R inbuilt function. It's also, it's about mathematical functions. If you want to find the square root of a number, you have to just type R inbuilt function sqrt. sqrt in bracket. You can type the type any number, then you can get the square root of that number, right? There is a function called sqrt to find the square root. Hope you all are doing with me, right? If you want to find the logarithm of a number, you have to use the function called log, L-O-G, log. In bracket, you can type any number. Just I'll type 100. If you run the command, you can see the output. It's 4.6. That means if you just type log in bracket, if you type a number, the base is exponent, right? If you want to get the log of 100 with base 10, you have to use comma here, then 10. Then you can get the output as 2. If you don't give any value after this, you have to first type the value. After that, you have to put a comma and give the base, right? If you don't give any base, by default, it will give the output for the base for exponent, right? In here, the base is exponent. In here, the base is 10, right? Did you all try these R commands?
Yes, madam, they have.
Okay. To find the exponential, you can use exp function. There is a function called exp. In bracket, you can give any value and find the output, right? If you want to round up a number, you can use the R inbuilt function round. Round, you can give any number with decimal. After that, you can mention the digits, number of digits after decimal, right? Then you can, in here, I gave a number as 3.45678, comma 2. I want to round up this number with 2 digits, right? So I'll get the output as 3.46. To round up a number, you can use the function round in R, right? Likewise, there are several R inbuilt function for it. R is built for statistics analysis. So there are many functions there. You can just type pi, simple pi, right? Simple pi, then run and you can see the value, pi value here. You will get the pi value, 3.141593, right? Now you can multiply 3 by pi, right? 3 star pi, then you will get the output. Likewise, there are many mathematical inbuilt functions. There are trigonometric operations as well. You can use sine. All letters should be in simple because R is case sensitive. In bracket, you can give any value. Sine 30, it's minus 0.98 because in here the 30 is in radius, not in degrees, right? So the output is minus 0.988. Likewise, you can use cost function. You can give any value and you can check the output. And all these values are in radius, right? This is now I want to explain some mathematical functions are inbuilt function. There are many functions. In here, I just explained some of that and how to get a output using those are inbuilt function, right? Is this thing did you all have done it? Is it fine for you all? You can use any function and check the output. Just type square root.
Yes, madam, it's fine.
Okay. Now we'll move to variables and data types in R. Right? In here, there are variable types, categorical, numerical, likewise logical. You can assign a value for x. X is equal to, in here I am going to create a numerical variable, x is equal to 40. And first you have to run those commands, x is equal to 40 and y is equal to 34. Then I can find the value for x divided by y, right? You can get the output, it's 1.17. First, you all, some of you only type this and you will run this and after that you will get an error. First, you have to mention that x is equal to 40 and run that command. After that, you have to mention y is equal to 34. You have to run those things. Otherwise, R don't have any idea about y and x values. So run all these things and you can see the output, right? If you create a vector or variable, you can see all those things in your environment tab, right? In here, I create a variable x is equal to 40 and y is equal to 34. You can see all those things in your environment tab. X is equal to 40, y is equal to 34. Now I am going to assign another value for x. X is equal to 56. Then in your environment tab, you can see that only there is a one x value is equal to 56. It will consider only your last command. If you run this x value, it will ignore the x is equal to 40, right? It will consider the command which you have run at last, right? So now x value is equal to 56, y value is equal to 34. Now you can do, likewise you can do many calculations. You can create a variables. I want to mention that you can create a variables here, right? Then if you create any variables, you can see all those things in your environment tab. Is it fine?
Madam, please wait.
Okay.
It's fine, madam. You can continue now.
Okay. Now I am going to create a characteristic variable. Now I am going to create a variable called name is equal to, you can give any name, just I'll give Nimal. Okay. In here, if you want to create a characteristic variable, you have to insert these inverted commas. Otherwise, otherwise you will get an error, right? If it is a numerical variable, you can just type x is equal to 56 likewise. If it is a characteristic variable, you have to use these inverted commas, right? You can run these things and you can see in your environment the name value for name is equal to Nimal, right? Just create some characteristic variables, right? If you want to create a characteristic variable, you cannot type the variable as numeric. You have to insert a inverted commas. Okay, right? After that, if you want, I'll explain these checking data types while we creating a vectors. Now, we'll create some vectors. I hope you will have a break now.
Yeah, madam, we will be returned within 15 minutes.
Okay, I'll continue the session at 10:15.
11:50.
Sorry, 11:50.
Okay, madam, thank you.
Okay.
Hello, madam. Can you hear me?
Oh, yes, I can hear you.
Madam, everyone are available now. You can continue the session.
Okay. Now, uh, we'll we will create some vectors, right? Now you all have to create some vectors. Now I'm going to create a characteristic vector, right? Uh, for example, in a classroom, we can have all your names with the marks, right? Likewise, I'm going to create a vector. You all have to create it. Name in here, there are going to be more than one values. So you all have to concatenate all those values. So you have to use C. It's simple C in bracket. Since it's a characteristic vector, if you want to type any name, you have to use these inverted commas, right? Just type some vectors. Uh, Try to create a vector, characteristic vector. Give some names, right? Since it's not a variable, there are more than one value. So you all have to concatenate it using a simple C, right? Just type 3 names, right? Sorry. Okay, in here I have created a vector. If you run this command, you can see it in your environment tab. It's a characteristic vector with 1 to 3 values, and you can see all your names here, right? Now I am going to create another new, it's a characteristic vector. You can see it here, environment tab. It's already defined. It's a characteristic vector. Now I am going to create a numerical vector, math marks, right? Equal to more than one value. So I have to concatenate all those values using simple C in bracket 45, 78, 67. Just give only 3 values and create a numerical vector, math marks, English marks. Likewise, you can give any values. Did you all create these 3 vectors?
Yes, madam.
Okay. Now using these vectors, I am going to create a simple data set, right? Data, I'll name it as data 1. Data 1 is equal to, you have to use the R inbuilt function called data.frame. Data.frame, right? In bracket, you can give these names. You have to give it say as it is, right? You can just copy paste or type. Don't make any changes in the letters. If you use simple letters, you have to use simple letters here, right? Use data.frame function, and you can, in bracket, you can give all these variables. If you give only 3 values in your name vector, there should be only 3 values in other vectors as well, right? If it is 4, you have to have 4 values in each vectors, right? If you run this command, you can see your data set in your environment tab. Now we are creating a data set. Use data.frame function. In bracket, you can give the variable's name, right? If you run this command, you can see the data set in your environment tab under data, right? Is it okay? Okay. Okay. Huh?
Madam, can you hear us?
Oh, yes, I can hear.
Yeah, madam, it's fine now.
Okay. Now, in your environment tab, you can see your data set, right? If you click here, this button, you can see the structure of that data set. There are three variables: name, marks, English marks. The first one is characteristic variable. The second one is numerical variable. Likewise, you can see all your variables if you click this button, right? If you click here, there is kind of dataset symbol. If you click here, you can see your dataset, right? This is our dataset. Now, it's a simple small dataset. If you click this button in environment tab, you can see your dataset, right? There are three columns with three rows, right? This is our simple dataset. Now we have created, right? This is our dataset. Right? If you want to know the structure of this dataset, there is a function called str. In bracket, you can give the dataset name. In here, I have named it as data1. You can give the name that you have given. You can see the structure of this dataset. There are three variables. The first one is characteristics, the second one is numerical, and this third one is numerical. Right? Likewise, there you can see the structure of the dataset. If you want to view the dataset, you can just click here, environment tab. You can see a button like this. You can click here and see the dataset. Right? This is a simple dataset. Right? Likewise, you can create using a data.frame function. You can create a data sets, right? Now we are going to import data sets. I have a CSV file and Excel file. I don't know whether all those files, do you have all those files with you? If not, we'll use some R inbuilt data sets. Right? Just I'll show if you don't have data set with you, then you no need to follow the steps. You can just see. I don't know whether you all have the data sets with you. Okay. Now I'll show you a data set. This is our data set, right? This is about height data. It's an Excel file. This is our data set. While doing statistical analysis, you can download any data sets. There is a website called Kaggle. In Kaggle, there are many data sets. Kaggle, right? In Kaggle, if you log in to Kaggle, you can see there are many data sets, right? If you click data sets, these are trending data sets, nutritional breakdown of foods, dating apps behavior. Likewise, there are many trending data sets. You can download any data sets. For example, I'll type nutrition, food, fast food nutrition data set. There are many data sets. You all can download these data sets and work on it. You can do an analysis and post it on in a social media, right? Like LinkedIn. Likewise, if you can post all those analysis there. If you want any data sets, you can download these data sets from here, right? It's a there are many websites to download data sets. The Kaggle is one of a data website, right? You can search any. For example, I'm going to search accident data set, US accidents. Likewise, there are many data sets in Kaggle website, you all can download all those things and work on it. Right, in here, for now, I am having a data set. Excel hide data. This is my data set. If I want to do analysis using that data set, I want to import that data set to R, right? For import, I think you all don't have the data set with you. So I show how to import. In environment tab, there is a button called import, right? Import data set. Then you can, if it is a CSV file, you can select from text base. If it is Excel file, you can select from Excel. In here, you have to browse your data set. Browse your data set. Then open. After that, import. Likewise, you all can work on this data set. If you first you have to import all these data set. To import data set, there is a separate R command. If not, you can just manually import like this. In environment tab, there is a import dataset called import dataset. You have to find the property of that dataset. After that, if it is an Excel file, you can use from Excel. If it is a CSV file, you can use from text base or text reader. Both are fine, right? Likewise, you can import a dataset and work on it. Right? Usually we use R for data analysis. So we have to use large data sets. We can import large data sets as well. R can handle all those things. Since you all don't have a data set now, there are many R inbuilt data sets, right? Now, data sets, you can just type, right? For simple analysis, you all can work on this as
Miss Aqeelah? Miss Aqeelah? Hello, Miss.
Can you hear me?
Yeah. No, I think the net was lost. Can you share the screen again?
I cannot share the screen. There is no permission to share the screen.
Can you try now?
Okay. Is it visible?
Yeah.
Okay. Now, use this command and see all your R inbuilt data set. In here, there is a data set called air passengers, likewise CO2, NAs, likewise there are many data set. You all can use this data set and work on it. Now we are going to do a simple exploratory data analysis using a R inbuilt data set, right? Now I am going to use a data set called data empty cast, right? In bracket, if you're going to use a specific data set, in bracket, use inverted commas. After that, type data set name, empty cast. Front. Then you can see it in your environment tab. Click here, then you can see under data. Did you all get this empty cast data set?
Madam, can you show it again, please?
Okay. There are many R inbuilt dataset. If you want to see R inbuilt dataset, just type data bracket. After that, if you run that command, you can see all those R inbuilt dataset. In here, dataset is there is a dataset called empty cars. Now we are going to do a simple exploratory analysis using this empty cast dataset. To get that dataset, use this R syntax, data in bracket, use inverted commas. In between inverted commas, you can type empty cars because the dataset name is empty cars. After that, run that command. If you run it properly, you can see it in your environment tab. There is a click here, there is a data called empty cars, right? Is it fine?
Madam, it seems there's a problem.
Why? Shall I wait for a few more minutes?
Ma'am, it's come under the values, not under the data.
Yeah. After that, you have to click here. Click here. Then you can get it under data.
Okay, okay.
Is it okay?
Please wait for 1 minute.
Okay.
Madam, you can continue now.
Okay. Now, if you want to view the data set, you can click here. In environment tab, there is a symbol like this. If you click here, you can see the data set. Right? This is our data set, empty cars. There are many columns, MPG, likewise, there are many columns and several rows. Right? If you want to see the data set, click in environment tab, empty cars. Click here, then you can see the empty cars data set. Right? If you want to see the structure of this data set, you can just type, or else you can click here, click this arrow button, then you can see all column names, whether the column is numerical or characteristic. Likewise, you can see if you want to get it separately, you can just type str function, R inbuilt function, in bracket, you have to type the dataset names, empty cars. Right? If you run the command in console window, you can see the output structure of the data set. This is our structure of the data set. There are 32 observations with 11 columns, 11 variables. Right? Use this command and get the structure of the data set. Can you all hear me? Can you all hear me?
Yes, madam, we can hear you.
Okay. Now we are using our inbuilt data set. Now we are going to do an exploratory analysis using this empty cast data set. First, we load the data set using empty cast function. After that, we viewed the data set using the environment tab. There is a button. If you press it, you can view the data set. Check the structure. To check the structure, you have to use this str. In bracket, you have to mention the dataset name, right? Earlier, we have created a dataset. If you want to find the structure of that dataset, just use this R command. In bracket, you have to give the dataset name, right? Now, in statistics, we usually, while doing the exploratory analysis, if we get the dataset, first we'll view the dataset. After that, we clean the data set. If there are null values, there can be many null values. First, we'll clean the data set. After that, we'll usually do exploratory data analysis. Then only we will do the main analysis in our statistics analysis part, right? In here, we are going to do exploratory analysis. Now we are going to check the summary of the data set, right? You all have to use summary function, SUMMARY. Summary function. In bracket, you have to give the dataset name. If you run this command, you can get the summary of this dataset. Is it fine? First run this command and get the summary of this dataset. While doing exploratory analysis, we usually first get the summary of this dataset, right? We all know there are 11 variables in our dataset. So each variable, we will get the minimum value. I'll show the output. This is our output. For each variable, there is a column called MPG, CYL. Likewise, for each column, we will get the minimum value and the maximum value, mean, median. Likewise, these are basic statistic, right? First quantile value, third quantile. Likewise, for each column, we will get the summary. Then we can understand what is the minimum value of this column and the maximum value, median. First, in exploratory analysis, we mainly use this command, right? Hope you all got the output. Now we will, in exploratory analysis, we usually do mainly the visualization part. We will just plot the histogram or box plot. Likewise, we will plot some graph to visualize the data set. Using this data set, we can find using this data set, we can use some of our statistic in there. Is if you want to find the mean value for one separate column, only that value, you can use the function called mean. There are a function called mean. If you want to access it, if you want to find the mean value for first column mpg, then you have to just type the data set name, then dollar symbol. After that you can select the column, right? If you run the command, you will get the mean value for only for that column. Likewise, you can get the variance, standard deviation. In statistics, while doing the analysis, we usually get these values: mean, variance, standard deviation. First, we'll analyze the basic statistic of that data set, right? Likewise, if you want to find these values, you can use this R inbuilt function, mean or variance. For variance, it's VAR. In bracket, you can give the data set name, dollar symbol. If you give the data set name, if first you have to give the data set name, then dollar symbol. Then you can get all the column names, right? Then you can select that specific column. If you run the command, you can get the output variance for WT column, right? Is it clear up to now?
Yes, madam.
Okay. Now we'll move to basic some of the visualization part. Now we are going to use this data set and going to draw a histogram box plot. Likewise, these in our exploratory analysis, we usually do this, right? What is histogram? Hope you all can remember these graphs: histogram, box plot. Histogram, to understand the distribution of a single variable. In here, we are going to understand the distribution of the MPG column, right? So, I'll type the command. You all can type the command with me. To plot a histogram, you have to use this hist function. In bracket, first type the dataset name, empty cars. After that, we are going to draw the histogram plot for MPG column, right? Dollar sign. If you type the dataset name and the dollar sign, you can get all the column names. Now I am going to plot a histogram for our first variable, MPG. So select MPG, comma. Now use main. Main equal to main means we are going to give a topic for that. While doing a visualization, we have to give a appropriate title for that graph. So I'm going to give a title for this graph. You can use main equal to, in inverted commas, you can type any name in here, histogram of MPG. After that, you have to name the x axis and y axis. To name the x axis, you have to use xlab function. Xlab is equal to mpg, comma, mpg. For y value, you no need to give that value. In histogram, it automatically calculate the frequencies of mpg and give the graph. You can give a color for the graph. Col is equal to, you can give any color. In here, I am going to give blue. If you run this command, become margins too large. I'm getting an error. Wait. You can just type this. In here, you can use this hist function. In bracket, you can give the variable name. You can give empty cast, $sign, and give the column name. Then you will get the histogram for this. After that, if you use the main function, you can give a title. Histogram. While doing a graphical visualizations, we usually have to name give a title, appropriate title, as well as we have to name the x axis and y axis, right? Then only it will show a meaningful graph. OMPG. Did you all get the graph? If you want to give a color, you can use this command and you can get a graph. If you want to name the x-axis, you can use this xlab function equal to in inverted commas mpg. Right? Likewise, you can get the graph. Did you all get the graph? If you in here, if you go to plot tab, you can see the graph. Not the file tab. You have to go to plot tab, and if you run the command without any errors, you can see the plot here. Right? Did you get the plot? Did you all get the plot? Go to plot tab and see whether the plot is there. Make sure you don't have any errors in this command. Then only you will get the plot. Did you all get the plot? Or do I want to wait for a few minutes?
Yes, madam. Everyone got it.
Okay. Now we are going to plot a box plot, right? To draw a box plot is to visualize the spread of outliers of a continuous variable like MPG. We are going to plot a box plot for MPG variable. Then we can understand whether there are outliers before doing the analysis. Main analysis, we usually do the exploratory analysis and check whether there are outliers. Likewise, first we'll to understand the data set, we usually do this exploratory analysis. To plot the box plot, you have to use the function box plot. In bracket, you have to give the variable. To give the variable name, you have to type the data set name, then the dollar symbol. After that, select the column. You can have a box plot like this, right? This is not a good graph. First, you have to, it should have a title. So, as earlier, you can use this main function and give a title. Box plot. for MPG, right? While doing a data visualization, the graph should explain all those things, right? So you have to give a appropriate title. Likewise, you have to give all those things. In here, just I show how to draw a plot. You can use this box plot function and draw a box plot for that variable. Okay. Hope you all done these things. Now we are going to understand, we are going to check the correlation matrix. What is correlation? There in here, there are many variables. You all know there are, I think, 11 variables. 11 variables in our data set. 11 variables in our data set. You can click here to view the data set. 11 variables. Now we are going to check whether there is a correlation between these variables, right? That means whether there is a relationship between these variables. To find that, you have to use correlation. Correlation. There is a function called COR, right? COR, and give the dataset name, empty cars. Then you can find whether there is a correlation. In here, you can see the output. You all have to run this command, COR in bracket, give the dataset name. Okay. Then you will get the output like this. In here, we can see the variable MPG and CYL variable. There is the correlation between those two variables is minus 0.85. There is a negative correlation. I don't know whether you all can understand this output. Since first you all have to have an idea about the correlation. Correlation means whether there is a relationship between these variables, right? While doing exploratory analysis, we usually check whether there is a relationship between the variables in a data set. To find that, using these values, we can interpret those things, whether we can find whether there is a relationship between these variables, right? If it is greater than 0.7, there is a strong relationship between those variables, right? Now, bar plots for categorical data. If you want to examine the count of cars by the number of cylinders, you have to have this graph. I'll just run this command and explain the graph. In here, number of cars. We are plotting a graph, bar graph. I hope you all know about bar graph. Number of cars by cylinder type. 4, 6, 8. There are 3 categories, and we are plotting a bar graph. After plotting a graph, we have to save it, right? This is not a R markdown file. It's a R script. So you cannot get the output near to your command. So if you want to, you can save this plot and you can add those things in your report, in your analysis report. If you want to save this graph, in here there is a button called export and save as. You can save it as an image format, or you can save it, you can save using this button. If not, you can save it as a PDF, save as PDF. Likewise, you can export all those graphs in RStudio. If not, if you use our markdown file, you will get the plot in our PDF or HTML file, right? This is our simple exploratory analysis using a R inbuilt data set, right? We have used empty cars are inbuilt data set. What exploratory analysis help to understand the data set, identify patterns, relationships, and issues like missing values or outliers. By visualizing and summarizing the data, you can generate hypotheses for further analysis or modeling. These are the basic steps while doing a statistics analysis. First, we define the problem. In our research, first we have to identify the problem, state the research question. Right after that, we collect data. There can be many missing values. So after collecting data, we have to prepare the data. We have to clean and format the data, and we can change whether it can be we can change the characteristic variable into factor variable. Likewise, we'll prepare the data set to user-friendly format, right? After collecting data, we have to prepare the data. Then we'll explore the data, use EDA. EDA means exploratory data analysis. Then we'll use the mean function, variance, likewise summary of the data set. We'll find whether there are any missing values and what is the minimum, maximum. Likewise, we'll explore the data set. Just explore to understand the data set. That's called exploratory data analysis. After doing exploratory analysis, we choose a specific test. Select the appropriate statistical method. Then we'll apply that method to the data set. Apply the test and interpret the results. Conclude, draw conclusion based on the analysis. After that, we'll present our report, present findings and visualization using the report. First, we have to define the problem, then collect data. After that, we have to prepare the data. Then to understand the data set, we used exploratory data analysis. After that, we find the appropriate statistical method to analyze the data set. Then we use those methods and analyze the data set further. After that, we'll get a conclusion. Then we'll make the report. In earlier, I show you the report. This is a simple report like that. In here, we imported the data set. Imported the data set. After that, data set overview. We have the structure. After that, we clean the data set. Clean the data set. Then prepare the data set to our analysis. Data preparation. We prepare the data set. In here, we change the column name. Likewise, we prepare the data set and change the data format. After that, we find the Bayesian network structure to learn this data set. It's a advanced statistical method, right? We'll find what analysis method is suitable for this data set to find the research problem. Then we'll use those those method and analyze the data set. After that, we will give the final conclusion, right? Advanced statistical analysis methods. After doing exploratory analysis, we find what method is suitable for this data set and to solve this problem. There are many advanced statistical analysis methods called regression analysis. Here I have shown you about the Bayesian analysis method and another analysis method called time series analysis, principal component analysis, cluster analysis. Likewise, there are many advanced statistical methods. After doing exploratory data analysis, we find what analysis method suits for this data set. These methods provide advanced insight and can be easily implemented using R. So, doing advanced analysis, it's easy to use R. So, we usually use R. For regression analysis, there are functions, R inbuilt function like LM, GLM. Likewise, there are many R inbuilt function to run all these functions, you all have to install the packages in specific packages in RStudio, right? Likewise, for each analysis, there are many analysis. Here I have mentioned only 4 analysis methods. You all can do all these advanced analysis using our software, right? Key insights of this workshop: understanding R. Hope you all understood R and R interface. What is RStudio? Then it's data exploration, statistical methods, hands-on analysis. You all, I hope you all did the exploratory analysis with me. Then you now you have an idea about this R markdown, right? To create a report, we usually use R markdowns, right? Then we can get the output as a PDF format. It's better to get the output as PDF or Word format, right? Thank you. That's all in my presentation. Do you have any questions?
Do anyone have any questions? If you have, you can ask now. Well, madam, it seems they don't have any questions.
Okay, it's fine. That's all. Thank you once again for being here today.
Madam, could you please wait?
Okay.
Now to conclude our IEEE is Kazumi Isan Secretary of IEEE WI Student Branch Affinity Group, University of Jaffna, to deliver the word of thanks. Good afternoon, everyone. On behalf of the IEEE Women in Engineering, Student Branch Affinity Group of the University of Jaffna, I am honored to extend our heartfelt gratitude to our esteemed speaker, Ms. MSF Aqeelah, for delivering such an engaging and informative session on mastering artwork statistical analysis. We sincerely appreciate the time and effort you devoted to guiding us through the practical aspects of statistical analysis using art. Madam, please accept this virtual token of appreciation as a small gesture of our gratitude. A warm thank you to all our participants for your active involvement. Your curiosity and energy make this workshop success. We look forward to your participation in our future events. Before we wrap up, we kindly request all participants to provide your valuable feedback by scanning the QR code. Have a great day. Madam,
Yes.
can you hear us?
Yes, I can hear.
Madam, could you please turn on your camera? Then we can take a group photo. Is that possible?
Okay.
Dear participants, I kindly request to take a group photo. So everyone please come in front of the projector. Can you come quickly?